Well, we finished 1A and now we're going to go on to 1B on this free response test. One thing to note, the way they have the FRQ set up now, you should keep both pages open. Don't fold over just to have one page, because quite often you will need some information on the previous page for the question. Keep both pages open so that I'm going to focus in right now on B. Typically, we'll end up having a page worth about 3 to 4 points, so you want to run between 6 and 7 minutes per page. So let's go on to this and see if we can answer it quickly. Here's the question. A student hypothesizes that the design of a heating pad could be changed to enable it to heat 150 grams of water by using a greater mass of calcium oxide. Use the data table below. Okay, I'm looking at it. It's a entropy table. Now, entropy, they didn't put the symbol S. That's interesting, but you should immediately think, okay, entropy, and it's got joules per Kelvin mole. So this is not enthalpy. First of all, we've got joules, and then, of course, we've got per Kelvin. Enthalpy change, the change in S for the reaction, in joules per, there's an equation for this. And if you go to the equation sheet, here it is, you'll scroll down and find the equation for entropy near the bottom underneath thermodynamics with all these other equations. But really, if you have to page forward to the equation sheet to get this equation, you're not really prepared for the exam. You should know this equation, the enthalpy equation, and the Gibbs free energy equation by heart. It's pretty simple. Back to the question. We're going to rewrite the equation. Now, you have your page open, so you might not have to, but I advise rewriting the equation because this is going to be products minus reactants. You would have to then remember this. You don't have to write the equation down, but you should show your work. And remember, we're going to be dealing with products, the right-hand side first, and then the reactants. Well, how do we end up doing that? Well, we look these values up and just do the calculations. It's going to be the calcium hydroxide minus the calcium and water, and they're all 1 to 1. So we don't have to worry about multiplying by coefficients. So let's get our calculator out. Calcium hydroxide, our product, 40, and this is in joules, and then minus, and I'm going to put the parentheses in just to make sure things work out well, especially sometimes you can get a negative value if you're doing enthalpies or Gibbs free energy. So that's going to be my calcium oxide solid, 83. There's only one of them, so I don't have to multiply. And the water, which is 70 joules per Kelvin. Okay, I've got it set up. The subtraction sign is there. I'm double checking. Yes, and this would be my answer. I'd write down what I had on my calculator. As you can see, here it is. If you don't write down your work, you automatically lose the point. So if you put a number into your calculator, put it on your paper because you have to prove you didn't cheat on this. And that's the answer that they've given here, negative 113. Now you've got to put joules per Kelvin mole. If you just put joules per Kelvin, I think they'd give you the point, but you need the joules per Kelvin. Enthalpy and entropy, you've got to show that unit. So this is good. We've got our answer. We get ourselves a point. 1 point for the correct answer, but only if you show your work. Is the reaction thermodynamically favorable at 90 degrees Celsius? Justify your answer with a calculation, and you can assume that both the change in entropy and enthalpy are constant in this temperature range. Well, again, you could go to your equation sheet and come up with the Gibbs free energy, but again, this is one that you really should have memorized already. You're going to be using it 3-4 times at least on the AP exams. So we will use that to find the favorability of this reaction. You have to know that Gibbs free energy is how you use to calculate the favorability of a reaction. Set up the equation and use our calculator again. And I already have that last answer in. I have, in addition to that, delta H. So that's a negative 63 22.7. Now this is kilojoules, so you're going to have to take that into account if you're going to be adding enthalpy, which is in joules. Put in my subtraction sign. My temperature is going to be 90 degrees, is what they're talking about Celsius, but of course we're not going to use degrees Celsius. We're going to use kelvins and then multiply it times our previous answer, which was the negative 113. Don't forget this is in joules, and we're going to have this in kilojoules. So I'm going to right now divide it by 1,000. I'm sure half the students get this question wrong and don't realize that enthalpy is typically kilojoules and entropy is joules per Kelvin. And this would be the equation set up. And notice they've got a kilojoule and they got units. It's written beautifully. You know, they had to do this because this is the standard way of answering things. You could have just written the numbers down if you wanted to. I very often will write the units just to remind myself what's going on. And a negative 22.7 to 3 significant digits. And let's see if that's the right answer. Negative 22.7. Let's go back and think about this. What did the question ask? Is the reaction thermodynamically favorable? You have to answer that question. If you just did this and that delta G is equal to negative 22.7, you would lose that point. Gone. Even though you proved it, you have to answer the question directly. Always go back and say, did I answer this question? And of course, that's the last part here. Yes, it is thermodynamically favored. That's what they ask. So yes, it's good enough. And then you justify that by saying delta G is negative. Now, in your calculation, if you had a plus here, it would indicate that it is not thermodynamically favored. And if you would have said yes because the delta G is negative, your answer would be wrong. But if you said no because the delta G is positive, you'd get the point for this answer. Your answer must be consistent with your calculation. 1 point is earned for indicating the reaction is thermodynamically favored. They really should say is consistent with your calculation, and you get 1 point for the calculation of delta G. Now this so far means that we've got 6 points. The question so far, just doing A and B gives you 6 points. The average number right on this exam, when the exam was given, was only 4.4. So if you got up to here right now, you're in the level of at least a 3. You're getting probably pretty close to a 4, 60% being a 4. So there, we've answered the question. Now I'm going to go back and double check. This is a negative 113. That makes sense because we're going from a solid and a liquid to a solid. We'd expect a drop in entropy. So the answer makes sense. I should have checked that after I ended up doing this. And I did answer the question. I gave them the answer that they wanted, and I showed the calculation that they wanted, and I answered the question. Remember, many students lose points because they don't answer the question. Make sure you answer the question. Okay, we've done B. Next, on to C.